Well, good afternoon. My name is Paulo Sotero. I'm the director of the Brazil Institute here at the Wilson Center. On behalf of the Brazil Institute and our Environmental Change and Security Program, also on behalf of George Mason University, have been our partner in this series on managing the planet. We're very happy that you could come to this discussion on climate change, science, impacts, risks, and response. Paul Schoff, from Chair of the Department of Atmospheric, Oceanic, and Earth Sciences at George Mason, will preside here and moderate the discussion. We are very happy to have Professor Andrew Light from George Mason. Paul will introduce each speaker in more details. We also have Glynis Lowe, Chief of Staff at the National Climate Assessment, the U.S. Global Change Research Program, and Professor Shukla, also from George Mason University. Just wanted to do a little celebration here with you because this marks the end of the third year of this program that will continue next year. Let me refer to Tom Lovejoy, who has brought this program to the Brazil Institute, to the Wilson Center. Tom is a great advisor to us, a member of our advisory board. We have, in these 3 years, we ran 18 programs. This year we had programs on the Global Environmental Facility, energy, making the Millennium Development Goals sustainable, the state of the oceans, and obviously the discussion we are having here. This will be the program, well, the one before last program of this year. I would like to invite you all, if you're interested, to a presentation that Ambassador Thomas Shannon, former U.S. ambassador to Brazil, recently returned. He is now a senior advisor to the Secretary of State and will be here on Thursday at 10 a.m. for a discussion on Brazil-U.S. relations. That just got very interesting this morning when there was information that a request for asylum, political asylum in Brazil by Edward Snowden, which has been turned down. I can give you the news. But Tom will be here to discuss Brazil-U.S. relations, and if you are interested, I hope, we hope you can come. With that, I would invite Paul to the podium, and thank you very much again for being here.
Thank you, Paulo. That was a very generous introduction. So the climate is changing, and this year's been rather a busy year. The Intergovernmental Panel on Climate Change has released the first of 3 of its reports. The first working group looks at the scientific basis of climate change, and that report came out in September timeframe, kind of telling us what we heard from the last time they did this. Climate is changing and humans are causing it. There's a good bit more certainty about those conclusions, and Professor Shukla will give us an overview of what's in that IPCC report and what's new and what we should be aware of. Well, it's one thing for the science to say it's changing. We are currently seeing impacts, and we're seeing changes and climate-related problems in the U.S., and the National Climate Assessment is undertaken periodically by the U.S. Global Change Research Program, and Glynis Lowe is here to fill us in on the most recent assessment, which was released for public comment early in 2013. The public comment period is over, and soon, early 2014, we're going to see the release of that assessment. So she is going to tell us about what the climate change that we've seen so far is causing us, the problems we're having, and what's likely to be ahead, perhaps. I don't know. And to wrap up our discussion today, humans are causing climate change. Yes, we're seeing problems associated with it. This was a year when the United Nations Framework Convention on Climate Change held its 19th Conference of the Parties in Warsaw to negotiate over what are we going to do about it. And Professor Light was at that conference as a senior advisor to the State Department, Special Envoy. And so he's going to give us the lowdown on what happened at Warsaw, or how the world is going to respond, or along that line, a view of the global outlook. So we're going to come up and speak in the order that I have a short talk from each of these panelists. They'll go for about an hour, after which we'll come up and sit here and open up the floor to questions from you and have a discussion, taking your questions. So with that, I'd like to invite Professor Shukla to come up, and we'll get his talk going, and let's go forward.
Okay, thank you. Okay, do you have the slides? Okay, good afternoon. Thank you for coming in this limited Christmas holiday shopping season and so many parties. Still you found time to come. I was given 15 minutes to talk about the science of climate change, but out of that 15 minutes, I will take 3 minutes to talk about science of climate, because after all, this is Washington, D.C., and even science should not be beyond politics, or cannot be. So I thought I'll take a few minutes just to give you some basic essence of climate science, because then that will follow the science of climate change. And nature provides us a very good example of basically understanding the fundamental climate science. And that's the fact, and I always ask this question to my students: why does it get cold at night? All the hands go up. Oh, the sun sets off. And then I said, but then you will get a B if you gave that as an answer, because that may be half of the answer, but that's not the full answer. So then, of course, immediately then there are not too many hands up. And there lies really a big sort of a question. And once you tell the students that if after sun sets in, temperature keeps going down all the way till morning. Why is that? There's nothing cooling it, is it? Well, the fact is there is. And that's really a very basic property of climate. Earth is constantly radiating energy out to the space, all the 24 hours, day and night. The only time we don't feel it is during the daytime, because sun is heating. And this is the property of every body, including us. We have certain temperature, we are radiating energy. The source of the energy is the food we eat. The source of the energy in the sun is the fuel that is burning. But this is a fundamental property, a physics property, that you are radiating energy all the time. What is climate then? Climate is exactly the temperature at which the amount of energy that Earth is radiating becomes equal to the energy that Earth is receiving from the sun. And that property, that how much energy any body radiates, is a very strong nonlinear function of temperature. So that basically defines climate. And we know that energy, and the fact that the energy that Earth is radiating is trapped, this is what is called greenhouse effect. And the amount of energy that is trapped and the amount of temperature that you will finally get directly depends upon the chemical composition of the atmosphere. So the fact that there is a carbon dioxide in the atmosphere, the fact that there is water vapor, that is why we have our temperature, global temperature, to be 15 degrees centigrade. If you take away all the greenhouse gases from the Earth's atmosphere, it will be very cold. It's not even clear that the Earth will be, that life will be sustainable. So this is fundamental physics, well known. There's no controversy about it. That's why Venus temperature is 700 degrees. And we're only 15 degrees because Venus has so much carbon dioxide. It is so the problem is not that the greenhouse gases, and carbon dioxide, one of them, is actually causes warming of any planet, particularly of the Earth. That's not really okay. So real question that is that is being debated and that I'll try to cover is that is the actual increase in the greenhouse gases causing the actual increase in the temperature? That's the basic science question. So with that basic introduction of science, and Paul, you'll give me a few minutes notice because I'll really try to cover 3 items, the actual change, and what is the cause, and what is the future projection. These 3 things, what the IPCC has said. This is the global mean temperature, and I think that we have made this as a definition that the global average temperature, if it is increasing, and you'll see 2 properties on this curve. One is that it's steadily increasing with time, and the other is it goes up and down. There are huge periods of hiatus, and I'll try to spend some time the fact that this overall increase over 100 years, particularly over the last 50 years, is human-induced. At least there is a scientifically, this has been the major conclusion of all the science work that has been done. And I think that I'll spend a little more time talking about the hiatus in this. And there is no sort of quick way, so many have things you have to take that this is the conclusions I'm only going to show you, because there are only 2 ways to test a hypothesis. You make a hypothesis, you do an experiment and see the result, or you make an opposite hypothesis and prove that it is wrong. Scientists have done both for this. They make a hypothesis that this curve is because of human activities, because of the CO2, greenhouse gases, and proven that that's the only way we can explain that. Then take out all the greenhouse gases and then show that it's absolutely you cannot get this curve. And this is what I'll show you in this. I'll show you very quickly what is happening now. And there can be a lot of slides, and I'm sure you have seen, a lot of these in the newspapers. But I think that the ice mass is decreasing. There is just a very clear quantitative evidence from this total. The fact that Arctic sea ice is decreasing is very, very clear evidence. I mean, this is sort of, there's a prediction about being ice-free. I could show you many examples of the loss of biodiversity. If you look at the actual sea ice, it has a very strong annual cycle. You can see that it just keeps going down and down into the minimum period. So you can see that there is so observations even during the past 100 years, and particularly during the last 50 years, are all consistent with the original hypothesis that I made. So I plot 2 curves together. One is the carbon dioxide that is increasing. The other one is the global mean temperature of the Earth. This particular bars is the same curve I showed you in the beginning. They're all increasing. And this is where the beauty of science is. Just because both curves are increasing together has absolutely no proof that one is causing the other. And the purpose of the science is to prove that. And how do we do that? And I'll break that into 5 questions. Just ask each question separately, because this is very important because sometimes this discussion gets very confusing because people pick up one piece of the question. Are the greenhouse gases increasing? There's absolutely no doubt about it. There was some doubt 40, 50 years ago when the Hawaii CO2 measurement showed it was increasing, and some people thought, oh, a lot of people are parking their cars near the observatory. So there was, but once they found out that this is also increasing at South Pole and North Pole, then that explanation was not valid. The point is that that's one thing that there's no doubt that it is increasing. Is the global mean temperature increasing? Yes, I think I already showed you it is increasing. Does the increase in the greenhouse gas cause global warming? Yes, I have already given you a 3-minute introduction. That's a basic physics question. So then, therefore, if the increases in the greenhouse gases are due to human activities, which we think they are, that is beyond any doubt. So if the answer of these 4 questions is yes, a logical conclusion will be that human activities are responsible for the global warming. But that's just an inference. It is still not a proof. How do we prove it? That was the purpose of the scientific community to do, and that's what the purpose of IPCC. And IPCC basically has 3 working groups. Almost all the major scientific institutions of the world, supported by their respective governments. I want to make it very clear, by the way. I stands for intergovernmental. So all the reports of this IPCC are approved by governments. It is a little bit awkward for us as a US scientist. I remember when I was member of the 2007, that after we wrote the report, our government said, I don't believe this, or we're not sure about it. But this is, this one, 2013, 20 groups from 13 countries have 13 models. And all I'm going to tell you is that what is the summary of these very massive international effort? What is the summary of the result? And how do you prove any hypothesis in science, especially for prediction? There's only one way. You make a prediction. There's no, if you're talking about future, you have to build a model. This is a climate model. I'm not going to give you all the equations and all the details. Just please remember that we're really talking about 10 million equations, about 10 variables, and you use most powerful supercomputers of the world. These are the models that are used for predicting weather every day for 3 days, 5 days, 10 days, which are later delivered by nicely dressed people on TV. But ultimately, the origin of that, all that output are these models. And what climate community has done is that basically extend that to the climate. So you take these models, integrate them once with and once without human activities. Means once with greenhouse gases, once without greenhouse gases. And you put all the greenhouse gases, all of them into the model, okay, including. And it's very important that you put all of them, because if you look at the temperature, if you just had carbon dioxide, the Earth would have really heated up a lot more. But you also have aerosols, which are cooling. So each of these factors are warming and cooling. We put them all together, and then you look at the final result. And here is the result for the 2007 IPCC. If you put none of the greenhouse gases, none of the human forcings, this is what you get, the lower curve. There's no warming. Only when you put all the gases, you get this curve. And on the same curve is the observations, which is in black. So if I have to say, what is one, that's my bias as a modeler, that what is the one slide for which the IPCC 2007 got Nobel Peace Prize, half of it, is this one. Because look at that, it is only now in 2007 that the separation between these 2 curves was absolutely clear. And so you remember the reason the scientists say we are certain, still they were 90% or 95%, because for the first time, almost all the models in the world, without introduction of the human influence, could not get anywhere close to the global warming of the global mean temperature. This is for 2007. This is for 2013. You can see still, I think the 2013 graphics are not so good, but you can see that the same result. Without forcing, global warming doesn't take place. With forcing, you get warming, and then observations and forcing runs are similar. So I think that the conclusion that IPCC came up with is that we have no other explanation. By the way, people also put solar forcing and so on, and this is the net result. So what is most important question from the point of view of IPCC 2013, because what has happened in the last 10 years, is the fact that just like in 1940s and 50s, there was a hiatus, there's also a hiatus now. And I thought it will be good at least to address that question, because this is the same curve. Here it's plotted from 1880 to 2020, so it looks kind of condensed. and you see the hiatus is very short here. But here it's just plotted from 1960 to 2010, and you see there is so this is kind of so just as the time when the political system was willing to accept the reality of global warming, the nature decided, no, I'm not going to change. So that becomes harder. Now, I will just give you very quick explanation, because each one of them will take a lot of time, but the collective wisdom of the scientific community is that it is part of the internal variability, because La Niñas, which are cooling the planet, were more frequent. And the second point, which is still being debated, is that the aerosol effects has been underestimated. We had actually a lot of small volcanoes, but we didn't put them, the IPCC didn't put them into this. So I think that it remains an active debate in the community whether this hiatus really represents the same kind of pause in the warming. There are a lot of papers that call what is the cause of the pause in global warming, or this is really a kind of multi-decadal variability which will go away, and ultimately the global mean temperature will just be in line with what is happening to Arctic, which is going. So right now, the real debate is that is it a temporary pause where the global warming, the global mean temperature will just come back with a vengeance once we are over this multi-decadal pause. And that's something that we just have to do more research to be able to give a definitive answer. So I think that very quickly, I'll now show you what did actual models, these 20 models, 30 groups, what did they give us? First of all, they showed that almost all of them, this is the warming in about degrees per 100 years, and almost all the models show warming anywhere from 2.5 to 5. And these are mean values. And this is something very important I would like you to remember. Climate prediction is probabilistic, whereas weather prediction is deterministic. In weather prediction, we say this is what is going to happen. In climate prediction, you can only give probabilities. That this is the mean value. So mean is 5. The probability that you can have 6 degrees or 7 degrees is still there. It's just not very high. So I think that the whole question should not be really, there's too much debate and discussion in the media about 2 degrees, 2.5 degrees. I'll come to that, why it is so. But really, it's a risk management question. That, okay, if it is 3 degrees mean, it could indeed be 6 or 7 degrees. These are the temperatures that have been predicted, and you can see that for different scenarios, how much CO2 we put, you can get very different numbers. These are the hot and cold days. That's very obvious. Hot days are going to be much larger, and cold days are going to be much smaller. Rainfall, actually, there's going to be a huge drawing into this belt, into the base. And I just said this is a busy diagram. I'm not going to, but there are areas where there's a tremendous amount of drawing. Ocean acidity is predicted to go. It has already been evidenced that the acidity is increasing of the ocean. And snow cover is clearly is going down very unambiguously. And of course, sea level rise. This is actually a very dangerous trend, because you see in the beginning here, more than 100 years ago, the sea level was rising at 8.8 millimeter per year. Then in this period, it was rising at 1.9. Now it is rising at 3.2 millimeter per year. So not only sea level is rising, it is accelerating the rate at which the sea level is rising. And of course, sea ice extent, you can see that is decreasing in all models. Ironically, none of the models captured the observations. In observations, it decreased even more. But look at see, they're all decreasing very much. So I think that I would like to close by a few comments. Of course, National Academy is considered to be a collection of wise people, and 200 of them at least were willing to sign an argument, a statement the last time. I think that the new IPCC is saying after all these modeling results, they are very certain about that temperatures in these two scenarios will increase 2 degrees. Why the 2 degrees is important? Just remember two things. During about 114 to 130 years ago, temperature was warmer about 2 degrees, and the sea level was high for about 5 meters. We had 5 meters high sea level. In about 5 million years ago, temperature was estimated to be 3 degrees, and the sea level was 15 meters. So the melting of the ice sheets is really one of the major long-term effects in addition to the biodiversity loss. And the last conclusion that I think that I would like to repeat what the IPCC, because IPCC published this, I think that it is extremely likely. By the way, you should know their terminology. They don't say 99%, because if it was 99%, they will say it's virtually certain. So extremely likely is 95%. Likely, very likely is 90%. I think that the collective conclusion of this calculation is that, yes, it is human-induced, and this has been the most important influence. Thank you very much.
Thank you. We'll take the questions at the end for the whole panel. So, Glynis, if you would.
Hi, everybody. I see Dr. Shukla and I wear the same shirt as well, same color shirt. So I'm going to try to cover a whole bunch of things. My name is Glynis Lowe. I'm from the National Climate Assessment out of the U.S. Global Change Research Program. And I want to explain a little bit of the process and the purpose and the background about the National Climate Assessment and why it exists and how we do what we do, because it's very important to our ultimate goal of communicating science to decision makers. I forgot to ask for how this works. Got it. So the National Climate Assessment is one of the mandates under the 1990 Global Change Research Act. So the Global Change Research Act of 1990 was a pretty impressive piece of legislation from the first Bush administration that required 13 federal agencies plus the Executive Office of the President to work together and coordinate all the research that they do related to global change. The GCRA, well, you can read the text, but it requires us to understand, assess, predict, and respond to human-induced and natural processes of global change. So the National Climate Assessment, which is one section of the rule, says that not less frequently than every 4 years, so quadrennially at least, the Council shall prepare an assessment which integrates, evaluates, and interprets the findings of the program and makes that useful to decision makers. Analyzes the effects of global change on a range of sectors throughout the nation. So what are things that are important to the economy, the water sector, the energy sector, and then also analyzes the current trends in global information that are both human-caused and natural, and projects those out 25 and 100 years into the future. But this report's supposed to be done every 4 years, but as it turns out, it is pretty difficult to make a comprehensive report like that every 4 years. So right now, we're working on the third one. The first two were in 2000 and 2009. If we'd done it every 4 years, we'd be working on the seventh one right now. But because, and you can still get to the 2009 report, it's been entirely turned into a website at nca2009.globalchange.gov. But because it turns out that it's so difficult to harvest all this information and present it in a way that's useful to decision makers on a quadrennial basis, right now we're working on the new National Climate Assessment, a new model of doing things. So we're really working on turning it into a sustained process. So instead of just harvesting this information and getting together the scientists and doing it, we're also working on how do we bring in stakeholder inputs? How do we really understand what stakeholders and decision makers need in this report in order to be able to support their decisions? And how do we update it on a continuous basis? So we have the goal of enhancing the ability of the United States to anticipate and mitigate and adapt to climate change, as well as evaluating our ability to do those things, and then also advancing this really inclusive and broad-based process that can take in inputs from all over the place. So this is a triangle and box view of the way our process for the NCA3 has worked, and this started back in 2011, 2010. First, we had a series of technical inputs from the federal agencies, universities, and NCA Net members. And I should mention here that NCA Net is a network of external partners that we have. We have right now more than 90 organizations representing over 150,000 members in those organizations who do things that we can't do within the program ourselves, but they take the information from the assessment and they make derivative products, they reach out to stakeholders, they're finding ways to make this information useful in the real world. So we got these technical input reports, over 500 technical input reports in early 2012. Then we have a series of chapter author teams. We have over 250 authors on the National Climate Assessment for our 30 chapters who prepared chapters which were then reviewed by the NACADAC, which is a federal advisory committee to provide advice to the government on how to produce this. A draft report was prepared in the fall of 2012, and in January of this year, it was sent out for public and expert review. We had a public review of 3 months, as well as a review by a panel of the National Academies of Science. Since April of 2013 rather, we've had multiple internal revisions of the draft report with the NACADAC and the chapter authors working to revise things. Right now, as of last week, the report is in agency and White House review, because although this report is developed by a federal advisory committee of the government, it is eventually adopted by the government and released as a government report. That's the government's view on climate change impacts in the United States. We expect that this third NCA report should be released finally in the spring of 2014, and it should be, we will have one document that represents both the views of the government and with concurrence from the Federal Advisory Committee. And then from there we move into this sustained assessment process, which really what are the intermediate products that we need to make to fulfill the next quadrennial report, and how do we get stakeholder input? What are the scientific questions that we need to answer? So before I'll run through some of the report findings that we have as well, but I wanted to point out that we have this a website called scenarios.globalchange.gov, and on there we have a number of the foundational science pieces that were prepared for this national climate assessment. So there are some regional climatologies and projections for all across the U.S. What have we observed? What's in the observational record for all the regions of the U.S., and what's projected to occur in the future? And then also global sea level rise scenarios and some discussion of how sea level rise will vary from region to region in the U.S. And I should mention at this point too that many of our graphics are heavily influenced by some of the seminal graphics that you just saw in the IPCC presentation. We also have a number of authors who participate in both teams, both in the NCA and the IPCC. And in general, we focus on making sure that we are consistent with the IPCC, although because we have a different focus, we are focused just on the US. We're not identical. Our findings are not identical to those of the IPCC. The outline for the third NCA, we start with a letter from the advisory committee to the American people, just saying, this is the framework, this is what we're seeing. We're seeing impacts all over the US. Then we have 11 report findings in the draft. Then we have a chapter on our changing climate. So what is the science of climate change, and what does it mean in the US? Then we have a series of sectoral chapters: energy, water, land, some crosscuts across things. What will climate change mean for transportation and agriculture? We also have chapters for each of the regions in the US. We have 8 regions plus oceans and coasts. We count as regions individually. And then new for the first time in this assessment, we have chapters on decision support, mitigation, and adaptation for climate change. So this is the first time these topics have been included in the NCA. And the NCA is not policy prescriptive. These chapters are not saying what the US should do about mitigation or about adaptation, but they're assessing the state of our knowledge about adaptation and mitigation. We also have an agenda for long-term climate change science based on the needs that are identified throughout the NCA process. And then a few additional appendices. One is commonly asked questions that answers a lot of the questions that are usually asked about climate change in a straightforward way. These questions in the full report are meant to speak to an average reader, not someone with scientific background. We also have one with expanded climate science info, because it's hard once you get going to fit everything you want to in a short chapter. So some of the draft report findings, and you might want to read these, you don't want to listen to me read them all probably, but some of the draft report findings, and we have 11 in the draft report that was released publicly in the spring. They range from the foundational science, so the fact that the global climate is changing and it's primarily due to human activities. that we've observed increases in extreme weather and extreme events, and those increases, some of them are related to human activities, and that this human-induced climate change is expected to continue if heat-trapping gases and emissions continue to increase. So we have this foundational science, and then we range through findings related to some of the sectors, and we have findings related to the state of adaptation and mitigation as well. So some of our graphics are not as data-rich as the IPCC graphics, but we're trying to communicate clearly that there are a lot of types of indicators that we've seen that we have actually a warming world, that climate change is real and having impacts in the US. We've seen sea level rise, we've seen temperature over land increase, glaciers and snow cover are melting. So some graphics that are meant to communicate clearly to a layperson. We also have some that look pretty scientific and very similar to what you've seen with the IPCC, that we show that projected temperature change in the US and globally is changing and projected to change over a range of scenarios. Some of our other report findings are about impacts that are already apparent across many sectors and many regions of the United States, and the types of impacts that people are seeing. That climate change is threatening human health. We have a whole chapter on human health impacts and the projections and possibilities for human health impacts. And then that infrastructure is being adversely affected. We have chapters on the urban infrastructure, chapters on rural communities, as well as transportation and energy. Some of the impacts that have been observed regionally are that heavy downpours have increased dramatically, particularly in the Northeast and some other areas. And if you look at the total US trend for heavy precipitation events or large amounts of precipitation falling very quickly, you see a strong trend over the decades from the 1900s to the 2000s. We have a lot of examples of Arctic communities, Arctic coastal communities being damaged, and a lot of evidence for the increase in billion-dollar weather and climate disasters in the recent history. We have a large chapter that gives a lot of the science about the water cycle itself. So the reliability of water supply is being impacted by climate change in many regions of the country in a variety of ways. Groundwater supplies, drought increases, all these types of impacts are discussed in the climate chapter. We also expect that there will be adverse impacts to crops and livestock over the next 100 years, though the innovation in the agriculture industry is likely to prevent major impacts in the near term. So this is one map of changes in plant hardiness and zone changes, so the freeze zones where different types of plants can live in the next 30 years. And then our final three report findings are about the natural ecosystems being affected by climate change and their ability to mitigate and continue to provide ecosystem services like clean water or coastal protection during storms. We also have seen that life in the oceans is changing as ocean waters become warmer and more acidic, and that also planning for adaptation and mitigation activities have increased in the US, but progress with actually implementing those plans and conducting adaptation and mitigation is still limited. So this is one map of observed. The black icons, which are all sorts of snakes and rats and butterflies, are observed impacts, and the white ones are projected impacts under climate change. And then we have a whole chapter on adaptation that gets into the specifics of which states have implemented adaptation plans and the general cycle for adaptation altogether. And with that, I just leave up a couple of these websites for more information while the next speaker comes up.
No, I don't have one. Thank you very much. I want to thank our hosts here at the Wilson Center. I was actually in the original meetings with Paul, I guess, a little over 3 years ago, where we sort of decided to initiate this this series, and so I'm so glad to see it's still going and thriving. Just before I begin, I'd like to please note, if you don't mind, that my remarks today are going to be off the record and not for attribution. I'm going to be speaking solely in my capacity here as a professor at George Mason, and not in my State Department capacity. So what I'm going to talk about, or what I've been asked to talk about, is the sort of the at least part of the solution side of the menu, not obviously the domestic agenda that we have in the United States, but I do want to actually come to that, especially the President's Climate Action Plan as announced last July. But the international side, what we're trying to do to create an international agreement to try to respond to exactly the sorts of science that has pointed out the gravity of this particular problem. I'm not going to assume that everyone has an understanding of the main body of climate negotiations that we're engaged in. So I'll give you a little bit of a review of that before getting to the outcome of our 19th meeting of the Conference of the Parties of the UN Framework Convention on Climate Change this past November in Warsaw. That process has obviously been going on for 19 years. It was initiated in 1992 as part of the outcome of the Rio Earth Summit. Out of the Rio Earth Summit, we got 3 big major international conventions on the environment: the Framework Convention on Climate Change, one on biological diversity, and a third on desertification. That treaty, which created this framework convention, was ratified by the U.S. Senate, went into force, and then since then has been meeting in a process which tries to create these individual treaties or protocols or legal instruments that follow from this framework convention. Because the parties, there's 194 parties who now participate in this process, because these parties were never able to come up with a means for voting, as we actually did in, for example, in other international agreements like the Convention on Prohibition of Trade in Endangered Species, the International Whaling Convention. We don't actually have a process in the UN Framework Convention, and so we use the UN default, which is consensus. So essentially 194 parties meet every year to try to make progress on creating an international climate convention, and every single one of them has a veto. So this makes the US Senate look relatively easy, I think, compared to the process we go through every year dealing with this problem. The first climate treaty that was created by, well, I should sort of back up one second. If you look at the language of the Framework Convention, and this is going to be important for where we are now in the process, one of the most important phrases in it is the phrase common but differentiated responsibilities, which is often abbreviated simply as CBDR. And what this points to is the part of the convention which tries to at least lay out in some kind of parameters how we want to divide responsibilities for reducing our emissions. So the nature of the phenomenon, as we know, with climate change is different than other forms of pollution. So the emissions in any part of the world commonly cause a problem in all parts of the world. We know that this is a particularly difficult problem because one of the primary greenhouse gas, carbon dioxide, is also a byproduct of the engine which runs the global economy, which right now is fossil fuels running the power sector, but also in transportation and the building sector and sort of other places. And so it makes a particularly difficult problem. So a core issue that the Framework Convention tries to deal with is which parties cut their emissions, how much, and on what time frame in order to achieve what we agree on as our commonly accepted climate goals. Our commonly accepted climate goal now, and it was officially embraced in 2009, and then again in 2010 when the meetings of the Framework Convention were in Copenhagen and Cancun, is to try to limit average temperature caused by humans at 2 degrees Celsius over pre-industrial levels. Now, as Professor Shukla already showed us, humans have already contributed, added about a degree of increase in temperature. So we're already halfway towards what we want to see in terms of the limitation of growth in temperature. And that certainly raises the stakes on the process. The notion of common but differentiated responsibilities is a phrase that points out, which sort of says that everyone, because everyone is polluting, everyone is contributing to the problem, has a responsibility, a common responsibility to help to reduce emissions, but these are differentiated. And they're differentiated by a number of things. In part, they're differentiated. This is certainly the sentiment in 1992. They were differentiated by the amount that you were contributing to the problem. Your historical emissions. Also, you could look at this measure this in a number of other ways. For example, by looking at per capita emissions by parties. But also important is development needs, because there is going to be some cost to transitioning away from traditional sources of producing energy. And insofar as there will be a cost incurred there will also be a lot of benefits and a lot of business opportunities. But insofar as there is a cost incurred in that, then developing countries should not be expected to reduce their emissions at the same pace as developed countries, or perhaps to the same extent. Now, that general notion, common but differentiated responsibilities, didn't get people very far in terms of providing them with a formula for how they would divide up reductions in emissions by parties. So the first treaty that was actually spun out of the Framework Convention, the Kyoto Protocol, which was finished in 1998, took a fairly crude swipe at this, divided the world into what are called the so-called Annex 1 and non-Annex 1 countries, the Annex 1 countries being essentially developed countries of the world, the OECD parties, developing countries being everyone else, regardless of their size, regardless of their contribution to the problem, and said that by 2012, in what was called the first commitment period of the Kyoto Protocol, the developed countries would reduce their emissions collectively about 5% below a 1990 baseline, and developing countries would have no legal requirements to reduce their emissions. There were a bunch of interesting instruments that were created as part of the Kyoto Protocol to help to encourage and incentivize reductions in emissions in developing countries. But this particular interpretation of the notion of CBDR made it very difficult for some parties to contribute to their full extent. The United States is the most interesting and significant of these examples. In 1997, the United States Senate voted 95-0 not to even consider entering into a treaty with the shape of the Kyoto Protocol, which had this differentiation in terms of annexes. And so that effectively put us outside of this process in some respects for quite a long time. If you know anything about this process, you know that 2009 was a big year when we gathered, the meeting came to Copenhagen in Denmark, and we tried to create a new comprehensive treaty which would bring together more parties. And there were a bunch of different theories about what this would look like, certainly one that brought into the United States as a full participant, but also one that would bring in the major emitters in the developing world, whose economic profile had changed quite a bit since 1992, China in particular. And while we didn't create an instrument that looks like the Kyoto Protocol, we did have a number of important accomplishments that you need to understand in order to see what happened most recently in Warsaw. I'll just mention three of them. First of all, the parties there agreed to they officially, what I said before, agreed to aim to limit temperature increase to 2 degrees Celsius, which was certainly significant. Secondly, there were two very important commitments that were made there in terms of finance. Because one way in which we can help developing countries to more rapidly reduce their emissions is to help to pay for their reductions. And this is not just simply a question of providing official development assistance or public finance, but also incentivizing private investment. So the developed countries there agreed to two targets. Number one, to voluntarily and collectively deliver $30 billion to developing countries for both mitigation and adaptation between 2010 and 2012. A commitment which was met. And then by 2020, mobilize $100 billion primarily using, but not exclusively using, a new institution which has now been created in the last 3 years, the Green Climate Fund, which will be housed in South Korea. The third thing that was done there was, that was incredibly important, is that parties agreed to essentially officially register what they were willing to do on a voluntary basis to reduce their emissions by 2020. And these are collectively known as the Copenhagen Pledges. There was a deadline of, the meeting then was in December, so by January, parties who were willing to sign up to the Copenhagen Accord would officially register their pledges to reduce their emissions by 2020. That's when the United States put forward its, the pledge we all know, to reduce our emissions 17% below a 2005 baseline by 2020. Along with those pledges, they started a process to create a system of what we call MRV, or measuring, reporting, and verification. So a process by which it wasn't just simply countries promising, like the United States just promising, to reduce our emissions 17%, but also agreeing to a formal process for how we would measure progress, report that progress, and then verify that in fact we were on the trajectory that we claimed to be on. So it took a couple years for everything that was agreed to in Copenhagen to get completely official, for all parties to come on board. That happened through the 2010 meeting in Cancun. And then in 2011, when the parties met in Durban, we actually saw the beginnings of the process that we're in the middle of now. So there's a lot that can be said about the Durban meeting, and I'm happy to answer any questions for those climate geeks like me who might be interested in knowing things. I should say the climate diplomacy geeks as opposed to the science geeks, right? No offense. I say that out of love, right? About what happened in Durban. It was a fascinating sort of diplomatic story. But essentially what we did there is we got two primary things. We created something which we now call the ADP, which for some reason stands for the Durban Platform for Enhanced Action. And the ADP has two work streams. The first work stream is the primary one we're working under now, and it was an agreement in 2011 that we should try again to create a global comprehensive climate treaty with a deadline of 2015 that would go into force by 2020, so for the post-2020 period. And the most important phrase that came out of this, especially for the United States, is that this new treaty should be applicable to all, meaning that the formula that we tried to use in Kyoto, which we never got complete consensus on around the world, of dividing the world between just developed and developing countries, not taking into account, for example, the contributions that different parties make to the problem, regardless of their previous development history, that this new treaty would be applicable in some way to all parties. So whatever level of legal stringency that evolves out of this treaty, it will be equally applicable to all parties. And secondly, that while that treaty will go, the intended treaty that we hope to finish in 2015 will go into force by 2020, that of course leaves the rest of this decade. And while I said that a number of parties, in fact over 80 parties, put up, representing over 80% of global emissions, did put up pledges to reduce their emissions by 2020, like the US pledge. There is a gap, a very well recognized and understood gap between, call it the ambition gap, between those collective pledges to reduce our emissions by 2020 and where we think we need to be by 2020 in order to feasibly be on a pathway, don't talk with your hands, so feasibly be on a pathway, or eat with your hands, or feasibly be on the pathway to achieve the 2 Celsius target. And there's lots of ways of representing this. The United Nations Environment Program produces an annual series of reports on the ambition gap that are important touchstone documents for those interested in this. So the second work stream is essentially on that, taking on the ambition gap, trying to get ideas from parties to increase our collective ambition somehow to try to close that ambition gap. So that by the time we get to 2020, hopefully with a new treaty in hand, we still have the 2-degree target within sight. Now, this brings us to Warsaw. So 2011, again, we're on this pathway to create a new treaty by 2015. We have 3 meetings between 2011 and 2015. The first one last year was in Doha. This last meeting was in Warsaw. We'll meet again in Lima in 2014, and then we go on to Paris in 2015, where we hopefully complete this process. So in Warsaw, I think in this respect, and I completely sympathize with folks who don't normally follow this process and then check in and kind of go, oh my God, how come you didn't come up with a new climate treaty this year? It's because it's a very long and very difficult diplomatic process, which is not aided at all by the fact, again, that this is a consensus process. But we are in this, by agreement, we have agreed to go on this pathway. And so in Warsaw, we saw, I think, a number of good steps forwards to finalizing this treaty in 2015, and also some individual accomplishments, in particular parts of the treaty, particularly in the forestry sector, but also in adaptation. The thing that was different for the United States delegation this time around was, in fact, the announcement of the Climate Action Plan. There was really a very different environment in the air for us there. Though we know that many of the things that the President announced in the Climate Action Plan were already initiatives both domestically and internationally which were underway, it should not be underemphasized or underappreciated that putting them all into one document, putting them into one signature speech, and having a transparent process to move forward on that climate action plan has helped a lot because it demonstrated our continuation of our commitment, not only to meet our 2020 target, but also to work internationally with our partners to move forward. And this really did help us quite a lot in the negotiating rooms. Our focus, we had a number of focus. Our main overall goal was, again, to build momentum towards a strong outcome in Paris. The view of the United States is that the right formula for moving forward to creating a new international treaty in Paris is not going to be, again, a top-down architecture like we saw with the Kyoto Protocol, but something more like that came out of Copenhagen, a bottom-up architecture, where parties come forward with nationally determined commitments of what they're willing to do in the post-2020 period. There has been no deadline set as of yet of what this new treaty, what its time frame reference will be, whether it will be a treaty that tries to sort of articulate what parties are willing to do by 2025 or 2030. That will still needs to be negotiated before we get to Paris in 2015, but it's one of the things that's under discussion. What the United States has a view that what we need to do is to create a process where parties come forward as early as possible and articulate what their target in the post-2020 period should be. And the reason for that is that rather than waiting till we all get to Paris in 2015 and put our cards down on the table in terms of what we're willing to do. If you look at it, for example, those of you who know the history of this, the US did not announce its target for the Copenhagen Climate Summit, the 2020 target, until about a month, right, before that meeting. Neither did China, neither did India. And that just doesn't leave you very much time to actually assess the adequacy of this kind of program. And if we are indeed in a world, and I think that this is where the ambition of parties is now, a world where different countries come forward with their own commitments, then we need a process that actually, where we can assess the adequacy of those commitments. So out of Warsaw, one of our main achievements in Warsaw is a commitment from all parties to begin moving forward to articulate what their post-2020 commitment shall be prior to the time we get to Paris. We have language in the agreed upon outcome document from Warsaw that said that those parties who are ready should be willing to put down a number by the end of the first quarter of 2015, so by the end of March. And that will allow for a process that can be run, that will be run by, you know, my good friend Shukla will be running this process from his laboratory and with his friends, assessing the adequacy of these from independent, outside, verifiable authorities. And this will be adequacy that you can apply whatever test you want. You can apply a test of adequacy based on for individual countries, but also obviously collectively, of whether or not people are putting forward collective targets that move us forward towards the 2 degrees Celsius goal that we have. And then if we announce this early enough, so let's say by the first quarter of 2015, and let's say imagine a scenario where all the major emitters, us and China and others, again accounting for, let's say, 80% of global emissions, that would be a good target, have put forward our commitments, then there will be a period for possible revision before you get to the final outcome in Paris. So we've now initiated by agreement to start that process, and I think that will actually improve the outcome that we will see in Paris. The other thing that we agreed to there is for assistance, that developed countries will commit to help developing countries to actually create their targets, to do their own internal assessment for how much they are able to reduce their emissions in the post-2020 period. And the United States already has a very ambitious program, which we call LEDS, the Low Emissions Development Strategies Program, where we work with many countries around the world to discuss their future low-carbon strategies that can be used to help to initiate and help it be possible for parties to move forward. And this will also make, I think, that these commitments that we see in 2020 as transparent as possible, and also allow us to share best practices for not only doing an internal assessment of what you can do to reduce your emissions going forward in the post-2020 period, but also how to increase that ambition. The United States has started its own process that's chaired out of the White House. Regular meetings are being held, and so the United States will be prepared to make a commitment on that schedule as we've agreed upon in Warsaw. Let me just 2 other things, and then we'll get to our final hour, and then we can start a discussion. There were a number of other outcomes in Warsaw. I mean, essentially, the big three discussions are always mitigation writ large, adaptation writ large, and finance writ large. But there were also a number of other very important outcomes in Warsaw. I'll just mention two of them right now. One is on a provision of what's called loss and damage, and this is a discussion that goes back a number of years in this process. And essentially the idea of loss and damage overlaps significantly with questions of adaptation, because it deals, for example, for how, what kind of process should we have to aid countries who are the victims of climate-driven events. But also importantly, the notion of loss and damage goes beyond notions of adaptation, because it's looking at climate impacts for which one could feasibly not adapt, such as the complete loss of sovereign territory, or indeed the complete loss of a country. And especially looking at Shukla's slides on sea level rise, we can understand this is a very real possibility. So as you would expect, this is an idea that was driven most forcefully and sort of at the impetus of small island states. And the small island states were successful in getting the creation of what's called the Warsaw Mechanism on Loss and Damage. And essentially what this will do will create a new freestanding body under, broadly speaking, the adaptation wing of the UN Framework Convention, but also importantly acknowledged in the text that we agreed to that in fact loss and damage conceptually can include things that go beyond adaptation. This body will continue until 2016, and then it will go through an assessment process, and that assessment process will then decide whether or not, first of all, it's working, whether or not we're coming up with good solutions and good programs to think about what to do with the specter of those really terrible, awful, some of the worst climate impacts we can imagine, but also whether indeed that is the right place for it within the convention, whether it should be under adaptation or someplace else. And importantly here, I think we're talking about not only a scenario where we're able to assess the adequacy of our knowledge sharing efforts and other things like this, but also really look at the adequacy of the Framework Convention as being the proper body to respond to this. Because we're talking about, for example, the displacement of entire populations. And there we really probably need something like at least the entire UN system involved in this. The United States, prior to the Warsaw meeting, joined something called the Nansen Initiative, which was initiated by Switzerland and Norway to actually try to account for exactly these kinds of future scenarios and prepare for them. The second thing here is that I'd sort of say that one of the areas where we've seen the best, some of the best work going forward, and this is entirely appropriate given that our co-hosts are here at the Wilson Center and the Brazil Institute, is that we continue to make great strides on creating global mechanisms to reduce emissions from degradation of forests and for reforestation. So at the Warsaw meeting, the United States announced, along with the UK and Norway, the creation of a new biocarbon fund initiative for sustainable forestry landscapes. The United States is contributing $25 million to this initiative, and altogether with those three parties, we'll have a pool of $280 million. The U.S. has long been working to try to increase reduction of emissions from degradation of forests and for restoration of forests. We made a commitment in the Copenhagen meeting in 2009 for $1 billion for work on in the forestry sector. We continue to be committed to this. This is a new initiative with additional monies, which really is aimed at working landscapes. How can you work in countries like Indonesia, in Vietnam, in countries in the greater Amazon basin, where you're actually helping people to make better choices with respect to their working landscapes and helping them to become better reserves for forest carbon, and also to prepare them for future restoration efforts. So those are, I think, the top lines of what we achieved in Warsaw, and look forward to the discussion. Thank you.
Okay, I'm going to ask our speakers to come up, and we have seats here, and we can take some questions. I do want to add a little editorial comment on one part of these discussions. You saw in Professor Shukla's and Dr. Lowe's discussions projections of the future, and there were like 4 of them. And these are due to the fact that as we try to predict what the climate is going to look like in the future, there's a bigger uncertainty than what the climate models are telling us. The big uncertainty is how much carbon are we going to release to the atmosphere? And the IPCC process came up this time with 4 sets of what are known as representative concentration pathways. It's like a projection in the future of how much CO2 is going to be released to the atmosphere, how much greenhouse gas loading is going to be put there. And these pathways were 2.6, 4.5, 6 point something, and 8 point something. Basically, those were if you release enough, if you stop your releases early enough to limit the rise to about 2 degrees, about 4 degrees, about 6 degrees, and about 8 degrees. So when you that explains why these forecasts going out in the future were diverging.
But having said that, maybe it is good to also say that what actually is happening is closer to the worst case scenario.
Yes, I was going to come to that. But there was also another important finding or important emphasis from this IPCC report. As Andrew commented, it doesn't matter where in the world you release the CO2. It causes warming. It gets distributed around the whole atmosphere, and it causes warming. So this report of the IPCC made another important point. It doesn't matter when you release it, whether it was 5 years ago or 5 years from now. We have a total number of gigatons of carbon that we can release from fossil fuels to the atmosphere and still maintain 2 degrees. If you release more, you're going to be at 4 degrees or 6 degrees or at 8 degrees. Doesn't matter when you release it. So that's another important finding, and it relates to what Andrew was talking about how we go forward in time of cutting our emissions, how slowly we bring those, if we bring those down slowly, we release more and we lock in a much bigger temperature change. So I just wanted to make that one little editorial comment. And now I think it's time to open it up to the floor. We have a microphone for questions. We're going to ask that you identify yourself. This program is being taped and live streamed, so we can, using the microphone, we can proceed from there. So let's start down here in the front. If you would identify yourself and to whom your question is addressed.
Yes, thank you, the panelists, for your speeches. I'm from China Daily, a reporter. My question is more concerned about China, because earlier this month, China released its blueprint for adapting to climate change. So I want to know your comment on this, China's position in global climate change effort, and I also know that the EPA administrator Gina McCarthy also just back from a trip to China where she met with Chinese officials talking about climate change and combating the air quality issues. So what's your comment on U.S. and China being the leader to combat or adapting climate change worldwide? Thank you. So Mr. Light, please. Or others can make complimentations. Yeah.
It's outside my purview.
I haven't looked at China's adaptation plan, so I can't comment. On it. I'll just say that I think it's obvious that the 2 biggest emitters in the world are U.S. and
Right.
China, and so we can't conceivably solve this problem unless they're both willing to make to reduce their emissions moving forward. Secretary Kerry is absolutely committed to everything that can be done to form cooperative plans to work with China to help to reduce our emissions. Obviously, this is a bigger issue for the entire federal government, and you're absolutely right about Gina McCarthy going to China as well to discuss these issues and what can be done, not only with respect to climate change, but these sort of these issues that certainly overlap, the air quality issues, which are also sort of a byproduct of carbon emissions. So the U.S. and China has a very active, vibrant climate change working group. There was a team from the State Department that was there last week working with them. It has a number of different pillars that you can find more information on our website. And we're looking for opportunities to move forward with cooperation.
Yeah, it's a well-known fact that when the Rio summit started, China was much less than the U.S. emissions. Now it's far more than U.S. It's by far the number one emitter.
Yeah, he meant from 1992.
1992.
The world looked a lot different. The world was quite different in 1992 in terms of emission profiles. Yeah.
Okay, so back there, and then we'll go to the middle of the back.
I'm Helen Raffel. I'm retired now, but I taught environmental science at Sichuan University in China for several years, and I'm in constant contact with my colleagues there and my former students who are working on climate change. What I'd like to ask, though, is, isn't a fundamental requirement for mitigation the accelerated decrease in the cost of solar panels and wind energy, so that they, in addition, of course, to the forestry question, and isn't it important for the government scientists to work on that? Because private scientists, private companies, will not want to give up their knowledge to other companies, other countries, and isn't it important to accelerate the circulation all around the world of the less expensive solar panel technology and wind energy? I guess to anyone who wants to talk about solar panels and wind energy.
Paul can talk about it.
I don't think we have expertise on business planning for mitigation technology here, but it is going to be key that we do come up with ways of sharing this technology around the world, propagating it at least.
Yeah, I think that's definitely a big focus for U.S. government outreach. If you look at so in the period I mentioned, there was this period of what we call the fast start finance period, following Copenhagen through to 2012, and the commitment from developed countries was $30 billion. The U.S. Contributed $7.4 billion during that period for mitigation and adaptation efforts around the world. An awful lot of that flowed through the Overseas Private Investment Corporation and the Export-Import Bank of the United States. And a lot of it was used, for example, to drive more private investment in, for example, solar power in India. So India has received almost $1 billion. Is the biggest single recipient of our assistance. But again, a lot of that money, in the hundreds of millions, came from OPIC and XM, and a lot of it was driven towards trying to expand the markets and the viability of the markets for solar power in India. And I think there's actually now, because of a study that was done last year out of, I believe, it was Lawrence Livermore, not NREL, that there's some potentially greater potential for wind resources in India than we had understood before. So I think that it's absolutely essential. I just agree with you on the emphasis and on the idea that is certainly part of this, and I think that is certainly the plan the U.S. has for trying to reach these bigger numbers of finance around the world, is to try to open up these markets.
Paul, that lady in the middle.
Okay, center of the back. Yes.
Thank you very much to all the panelists for your presentations. My name is Alice Thomas, and I'm the Climate Displacement Program Manager at Refugees International. And Andrew, I have a follow-up question for you on the comments you made on this issue of what people call the climate refugee. And this is the idea that people will be displaced outside their own country because of climate change. Potentially, entire countries could lose their territory. My question is really, what is the right venue for this? Because you mentioned the Warsaw Mechanism on Loss and Damage, under which they have discussed looking at the impacts of climate change on displacement. And I'm wondering whether you see that as a fruitful way to pursue solutions to this gap in legal protection for people who are displaced by climate change. Because as someone coming from the refugees world, as we saw clearly 2 weeks ago or 3 weeks ago, nobody has yet been granted asylum as a climate refugee. And really under the convention, it would be, for reasons that I won't go into, it may not be the best venue itself to extend a new category of protection to people who are displaced by climate change. And given the political realities within the UN Convention on Refugees Convention, it's very, very unlikely that the signatories to the Refugees Convention are going to do that anytime soon. So as somebody who's been working on this issue for a while, I don't know what the way forward is. And you mentioned the Nansen Initiative, which I think is very positive that the United States has joined to support that initiative. But I was just at the Nansen Initiative regional consultations in Costa Rica 2 weeks ago, and the U.S. wasn't there. And I'm wondering what the U.S. is going to participate, what it's going to contribute to that, and whether you think that is ultimately the way that the U.S. is going to engage on this issue, or whether, I should be going to the climate negotiations and looking at loss and damage more, or whether there are other ways forward. But right now, I don't see any plausible solutions to that legal gap.
So I'm not being a lawyer. I can't really comment on the issue at all about what's the right legal mechanism and the legal definition. I do understand that is a very difficult and important question. I'm happy to connect you with the person at the State Department who initiated the U.S. That initiated the U.S. joining the Nansen Initiative, and so. And she'll be able to tell you about what our plans are kind of moving forward. As far as the propriety of the Warsaw Mechanism on Loss and Damage to deal with these legal questions, it's clear to me that if you look at the negotiated text that we came up with, other than describing the phenomenon and looking at a few and highlighting a few important issues, such as looking at means of implementation and sort of these kinds of things, there's not any strict parameters that says, well, we can, or we can't talk about certain issues and only will talk about other issues. So in that respect, I think the mechanism on loss and damage is going to be what we make of it. And I think that it's something, it was really quite stirring to see the parties come together after having, I think, what anyone who looks at this process acknowledged as a very difficult meeting over these issues in Doha a year ago, to finally come together and agree to create this initiative in a structure and a framework that everyone was comfortable with moving forward. So hopefully it will. I mean, I hope that because I worked very hard on making sure that mechanism got created, and I hope that it will be able to answer some of these more difficult questions, like the ones you mentioned. But whether or not it will, in fact, be able to do that, we just won't know until we actually start doing the work. The first thing I'm going to do is, create the body, get the right people around there, set the right kind of agenda, and then move it forward.
Okay, we have down in the front here, and then over there.
Thank you, Paul, and thank you to the panel. I'm John McCormick. I'm with the Institute for Multi-Track Diplomacy, and I'll direct my question and maybe a comment to Dr. Shukla. Your charts on increased global temperature were land-based temperatures, and it showed a leveling off post-1998, which was the year of the El Nino that broke all records. Now, in that 15 years since that El Nino, we've increased CO2 concentration in the atmosphere by perhaps 25 or 30 parts per million. So my question is, that heat, which the Earth has taken up and hasn't radiated all of it out, obviously must be taken up by the oceans, and particularly the Western Pacific. So we're building up to possibly a very massive El Nino in the future. But would you discuss a bit how the temperature increase is perhaps being banked in the ocean?
Yes, thank you for the question. First of all, the temperatures I showed were global mean. They were both land and ocean. And our opinion is that a lot of that extra heat went in the ocean. But since ocean heat capacity is so large, the actual temperature increase is very small. Still, it can take up a lot of heat. So in the fact that there were several La Nina events during the last 15 years actually contributed to the fact that we didn't increase. See, the temperatures have not gone down. It's just that they haven't gone up as much as they were going before they have. So I think that, as I said, there are three explanations. I had in my table, but I didn't say, so thanks for reminding. One is the fact that more heat is being taken up by the oceans. And there's real data to show that. And the other one is La Nina, and the other one is not taking into full account of the cooling because of smaller volcanoes and aerosols.
I'm going to chime in here as an oceanographer involved in it. Yeah, there's a lot of heat that's been gone deeper into the ocean than we otherwise had expected. We think of the ocean interaction with the atmosphere. Professor Shukla talks about the global mean temperature over land and ocean. It's the surface temperature of the land and surface temperature of the ocean, surface temperature of the ice. In order to account for heat, you've got to account for all the temperature rise throughout the ocean column. And that's been moving down deeper in the last 10, 15 years than we originally expected. So the part of this, whatever's happened in the last 10 years has involved a deeper, the heat is still getting trapped. It's going deeper into the ocean than a thin skin layer would otherwise say. So that seems to be the outlook. The other factor that's gone into this is that ice has been melting a lot faster. Global ice, both sea level, sea ice and land ice. You put heat, trap heat, it melts the ice without changing the temperature. There's been a lot of that still going on. Yeah. Okay, we have over here in Burgundy,
In the
second one in there.
I'll just follow up on the last one because there's also, and this came out after the work on the IPCC. This is for, well, mainly Dr. Shukla. The report that just came out that it's actually the treaty to ban refrigerants. Yes. That was that would do the opposite of the ocean because that treaty supposedly also slowed global warming because the refrigerants aren't in the atmosphere. So are you taking that into account at all in the IPCC? And yeah, okay. Well, that's pretty much the question.
Yes, actually, if I showed you the list, and CFCs were part of the input into the scenarios that are being run. Some of these estimates have not been as robust as you were right, but the amount of heat that we need to explain is, of course, far more than what can be explained by these factors. That's why the ocean uptake and is one of the very important ones.
So it's probably multiple.
Yeah.
I could ask a diplomatic question.
Diplomatically,
completely
yes.
different, which is there are all kinds of treaty like the TP. I don't know if you know the TPCC, like different treaties to lower trade barriers, and there's a lot of contention that you then get environmental a race to the bottom. So, for instance, if industries move to China, they might. It doesn't have the same environmental standards. Therefore, it's going to release more carbon dioxide, making the same amount of products, and therefore China is way ahead of everyone in the world in releasing carbon dioxide. And whether that's worked at all into the internet, like whether the treaty system is just something completely different.
Whether the trade treaty
The
system is
trade,
different?
exactly.
It's different than the framework convention for sure. Yeah,
and
absolutely.
whether you take that into account in the
there- there-
negotiations, or
Well, so one thing I did want to mention is that while my friend Paul asked me to come and talk about the outcome in Warsaw, if you don't follow this kind of work very closely, I hope that you all will be happy to hear that we have lots of other processes around the world that are trying to reduce greenhouse gases. In fact, you just edged up to one of our main priorities in the U.S. government right now, which is using the same treaty that phased out CFCs, the Montreal Protocol, using that to phase down hydrofluorocarbons. And this has been a major. I was working on this at the Center for American Progress there for a number of years before joining the State Department. It's a big priority of the White House, and this has risen to the level. To the leadership level, right, of diplomacy between President Obama and his counterparts in China and India to try to move towards amending the Montreal Protocol to phase down HFCs. And there's a treaty that worked, right? There's a treaty that was actually successful in doing what it set out to do. It's a treaty that includes a mechanism for differentiation, which is not as strict as this common but differentiated responsibilities notion has been employed in the Framework Convention, but it allows for differences between developed and developing countries. It has a financing tool in it, a multilateral fund, to help developing countries who normally will work on a longer time frame to phase down their gases or their chemicals in this case. And like I said, it's got a proven track record, so that's one of the areas we'd like to move forward. There's a bunch of other things, and we can say more about them later. We have an entirely separate process just aimed on, we often refer to HFCs as short-lived climate pollutants or short-lived climate forcers, or they're trying to be rebranded now as super pollutants, but it's not quite caught on yet. But, it'd be great if it did. And so it includes not only HFCs, but also methane and a very powerful driver, which is soot, so black carbon. And we've got a coalition of countries, over 30 countries now, called the Climate and Clean Air Coalition on short-lived climate pollutants, which is aimed at cooperative measures to reduce those gases. And so on the trade scenario, I think that you're right. I mean, if you had I don't know about the particular trade mechanism you're talking about and the worries there, but of course any mechanism that would drive more industry to a country that was not contributing to reductions in its greenhouse gas profile would be difficult, would be a problem. And that's why we want a treaty that's applicable to all parties, right? That's why we want everyone, especially the major emitters, which are also the biggest industrial economies, which produce most of these goods, to be all in this together. The Asia-Pacific Economic Cooperation Program, in fact, has created a trade program in the opposite direction, to lower trade restrictions on environmental goods and services. So all the things that go into solar panels and wind turbines and all of this kind of stuff, measuring equipment, all kinds of things, to try to do that. Part of the President's Climate Action Plan, if you recall, is to take something like that model and apply it to the WTO, which would be the entire trade architecture of the planet, to get it all sort of moving in the same direction. This is something that was tried to be done, we tried to do a number of years ago during the Doha round of trade negotiations, but sort of got left in stalemate along with many other things there. So I think the question, the big challenge that we're taking up now, right, is how can you use these other trade forums, in fact, to help to drive positive momentum on the future scenarios we'd like to see.
Okay, thank you. Okay, down in the second row here, and then we can go to the first row.
Dave Rabinowitz, I'd like to ask each of the four of you, are you basically optimistic or pessimistic, and why? And please feel free to define optimism.
We'll start at that end.
Chair's prerogative.
Professor Shukla.
Oh, I see, yeah. Oh, I'm just eternally optimistic in life, so my general answer is yes. I mean, the fact that we're talking about it, look at all the meetings and treat, I mean, sometimes when Andrew was talking, I said, gee, this must be a different planet where those meetings are taking place. It can be U.S. Senate. It can be what's going on in Washington. So I think that the fact that we understand the properties of this molecule, CO2 and other, the fact that we are beginning to sort of have development in technologies, I'm generally very optimistic. The only thing is that I worry about all the forces which are constantly trying to confuse people and try to create doubt, what has been referred to as merchants of doubt, because this is delaying the process.
Dr. Lowe?
Finally, something that I'm allowed to comment on. There's a lot of things with the NCA being not policy prescriptive that we shouldn't say, but I can say from a personal perspective that that I'm very optimistic, and a lot of that optimism comes from the capacity for action. There's a lot of capacity and growing interest in action, both on mitigation and on adaptation. And there's a lot of local activities, a lot of state activities, a lot of national activities and international activities working on what is it that we can do to prepare for these changes? How can we be more resilient? So I think there's a lot of room for optimism in preparing for change.
I feel the same way on this, and I know that it can be easy to get very pessimistic on this because of the stakes are so high, obviously, and because changes don't happen as quickly as they should. One of the things that, if you haven't been to one of these annual UN climate summits, which is really sort of it's the 2-week process that occurs every year, but then there's lots of these interim sessions that go on throughout the year where a lot of the hard work gets done. But I think that I've always found, ever since I started going to these a number of years ago, what really gives me hope is not so much what's going on in the negotiating sessions, but what's going on outside of them. Because these annual meetings are also, if you've been to them, it's like the biggest climate bazaar and conference, and I mean bazaar, like where you buy things and stuff, right? Not bizarre.
No, with an
right,
I.
right.
It is
with an A.
I.
with an A. It's the biggest, climate meeting of the year in terms on the solution side. That's what's most impressive, and it's just in the hallways, booth after booth after booth after booth, and it's municipalities, right? It's states, subnational units of all varieties, it's intergovernmental organizations, it's private companies, it's NGOs that are taking on like every conceivable part of this, the forest section, biochar, the smart ag people, all these different gases, all these different initiatives we're talking about, every conceivable form of renewable energy. And that's what's really encouraging, is because you know that every single one of those people in that hall stands for thousands, right, of people who are not in that hall, who are every single day getting up and pursuing these kinds of solutions. And I think that, at the end of the day, is going to be a force, that will make change. This is why when students ask me, my own students ask me, like, what can I do to get involved? I'll say, go to one of these COPs, go to one of these meetings. Yeah. And you just walk through the halls, and if this is what you want to spend your life on, and so many of them will be spending their lives on these issues, you can just sort of figure out where do you want to sort of put down your marker. It's right there in front of you.
Including a group that wants you to be vegetarian. This is a very active group that really thinks that if we all become vegetarians, we actually can really kick this problem.
Okay, well, I will finish with I'm an optimistic cynic. So my take is that with enough super typhoons and enough big damages from the ongoing climate change, that people are eventually going to wake up and do something about this. And the part of it, the real core of my optimism, it comes from talking with young people. I was at the American Geophysical Union last week with 25,000 scientists, and we were at Jim Hansen's talk, and I somehow got sandwiched in with a group of secondary students that were there on a tour. And so I started talking with them before the talk about, you know, whether they knew why a greenhouse gas was a greenhouse gas and things like this. But you got the clear sense, there's a clear sense that that generation of kids get it. And they're not going to put up with it. And so it seems to me that by the time they get into power, something will be done about it. But to go along with my opening remarks, it's the total amount we emit, and hopefully we can taper it down before they get to stop it. And so I'm concerned, you know, somewhat about that.
Paul, can I comment? It will be good in the scientific tradition that we don't agree on everything, even among the panel. I just want to clarify that these hurricanes and typhoons that Paul mentioned, I feel that kind of is not the right sort of argument to make. You can have a temporary benefit, but you can also really, and I mean, look at this hurricane, Atlantic season had really no major hurricanes. So the science about the direct connection between the climate change and the intensity of the hurricanes is still evolving, and there may be a hiatus sometime, and then it will not be a very good thing. So I think we need to sort of keep a perspective that there are certain phenomena which are going to continue to be there irrespective, and our ability to demonstrate and prove, especially to a skeptical crowd, is not going to be very good for a while. So it's they're doing the job. They're doing the job, actually.
Yeah, scientifically, I agree with you.
Yes,
I'm
yes.
just in the fearmonger shop.
Right,
you
right.
know? I mean, if we can get enough, you know, you can energize a lot of people with fear. But as you said, now I have one other piece of optimism, and that is the little piece of news that ExxonMobil, Walmart, Mars, McDonald's, a number of the largest corporations have recently revealed that they are pricing in a tax on carbon to their business projections going forward. So, you know, when even ExxonMobil is looking at and anticipating a price on carbon, there's some room for hoping that that interests, financial interests, are going to be are aware of the consequences of not doing something about the climate, and are, you know, anticipating that there will be things to affect their bottom line, and therefore they're going to be planning for it. So there's other signs that things may be going in a good direction. Okay, so now we're down to the front row, and then in the middle of the back row, he's had his hand up earlier. I missed him, so we'll get back to you.
Yes, I'm Richard Kennedy, a retired CIA analyst, economic analyst, I should say, and also the father of a PhD student at George Mason. But in 1992, I think I wrote a paper on environmental policy in Europe. It was, which exposed me enough to the science of global warming to be persuaded that it was a serious problem. And the evidence, of course, has gotten a whole lot stronger in the last 21 years. And yet the opposition to accepting it also seems to have gotten stronger, to the point where you even have Republican senators saying the whole thing is a hoax. I just wonder if you have any thoughts on why it is so hard for the science, which seems so clear to me, to penetrate more into the minds of our political leaders.
Did you ever hear of tobacco? There's a strong analogy with those interests in continuing to emit carbon and their techniques toward dealing with the CO2 problem that the tobacco industry took.
You have asked a question that I ask my students in my class. I said, I'm an immigrant. I'm from another country. Can you guys explain to me how come? This is something that is so well known scientifically. There's a scientific basis. But if you plot a table of people who strongly believe and people who consider it hoax, 2x2 table, and then make another side, whether you are a liberal Democrat or a conservative Republican, it's so well separated. So it's a completely ideology-related distribution. And as you say, I can't, at the risk of sounding scientifically arrogant, I'll say that if they are honest people, if they are honorable people, then they're just misinformed.
Okay, so they're in the back.
Hello, good afternoon. My name is Jeremiah Asaka, and I'm a student, master's student at Ohio University. I'm taking environmental studies. My question is more on the response to climate change, and more so on a global scale. I think it will be in the docket of Andrew, Mosley, and Shukla. For a long time, there's been a focus on mitigation, and then at some point, adaptation came up. So my interest is in knowing whether you think at some point adaptation may take over and mitigation gets a less focus, and if so, what would be the impacts of such a shift? Thank you.
Looks like this is a question for you.
In general, there's a lot of discussion about the combination of adaptation and mitigation and looking at both of them together. And in many ways, actions that you take for mitigation or adaptation can help you with the other. So if you're mitigating, you need to be reducing your emissions or increasing your uptake of carbon. It can also help you with adapting. It can also help you with planting new grasses that will thrive in an area and help you maintain your soil so that you don't have as much runoff from the agriculture when you have heavy downpours. So there's a lot of interactions between these two. And I think that in general, I haven't thought about the possibility of one overtaking the other eventually, but in the near term, we need to be focused on both. We need to be focused on how we can adapt now and what we need to be preparing for, but also the amount of mitigation that we do now affects the amount of adaptation we'll have to do later, and the amount of adaptation that we do now affects the dramaticness of the mitigation that we'll need to do later.
I agree with that, and I'm sure Andrew has something else to add, but adaptation has to be very important because something called climate commitment. We have already made certain amount of climate change commitment. The very fact that we have introduced certain amount of gases, and they will remain there. And therefore, if you stop increasing emissions today, still the temperatures will keep increasing. So adaptation has to be a very important element. But I'm sure Andrew may have something.
No, I don't really have much to add. I think that's absolutely right. And I think that there definitely has been a shift that you can see over time. I mean, but I think it partly is not a shift. If you go back to the early 90s and then go to the shape of the discussion today, there was sort of probably a moment somewhere in there where if you raised the question of adaptation in a discussion on climate change, people thought you were giving up, right? Or you weren't really serious or something like that. And I think that's really changed, and it's changed really because of just how much more we know. I mean, we know so much more about what we've committed ourselves to physically, in the Earth system. And also, I think clearly what we have to come to grips with is also what we've committed ourselves to politically, frankly, and economically. There's some incredibly interesting work that's being produced, for example, by not just Michael Oppenheimer at Princeton, but kind of others who are looking into this, trying to measure, for example, how much we're potentially locking in based on infrastructure, right, for burning fossil fuels. How much do we lock ourselves into in terms of future emissions every time we build another coal-fired power plant? I mean, this is why things like the Climate Action Plan are so absolutely important to move forward with these regulations on the power sector in this country and hopefully in others.
So we had one back there, then we'll come down here. Okay.
Hi, Bob Kozak with Advanced Biofuels USA. To Andrew, going a little bit more into the loss and damage side of things, I guess the key question is, what are the plans for financing that? And the reason I bring that up is having property in Maryland and just noticing that general rates have gone up in Maryland basically to start covering for what the reinsurance agencies are telling us right now about the Eastern Shore. Is there talks about when you're talking about loss and damage, are you talking about discounting current present value of the land and properties that lost, or is the plan to continue what's happened in Sandy, which I personally think was the wrong way to go, was to basically pay at current present values for properties that you know are going to be wrecked again within a decade? So I guess it's a two-part question. Are you looking at some sort of discount on that? And with the fact that the reinsurance agencies are talking about the huge dollar value, just hundreds of billions of dollars it's going to cost, even, say just in the United States, how is that going to be financed?
Well, the loss and damage program in the Framework Convention is aimed at developing countries, right? So it wouldn't really speak to the particular issues that we're facing in a country like the United States. I'm sure there are going to be parallel issues, obviously, in those countries, and this is part of the purpose of starting this mechanism or working group to try to look at some of those issues. But our expectation is that there was a time, say in the short history of this discussion, where many of the advocates for loss and damage were focusing mostly on it as a compensation issue. And we really saw that drop away at the Warsaw meeting, which is partly why we were able to come to an agreement on creating the new mechanism, which I think is a healthy step to move forward. It really sort of cleans the table so you can kind of move forward without any preconditions. But we have committed ourselves to a very large figure, mobilizing $100 billion annually, from 2020 moving forward. And it's going to be difficult to hit that amount. So we're not looking at any sort of part of the convention right now which would add significantly to those commitments. And right now sort of focus on what we can do to make that happen. So through the State Department, for example, we've initiated a number of what we call finance ministerial level meetings over the last year, aimed at looking at these ways, and it goes to an earlier part of our discussion, for mobilizing private finance, using public funds in the mitigation realm primarily, but conceivably in sort of other realms as well. So that's kind of where we are in terms of that mechanism. It's not really far enough along yet to commit to those kinds of programs. But I do agree with you; those are obviously tremendously important questions that particular countries are going to have to face.
Down here.
Hi, thank you very much. My name is Sid Hamilton. I'm a AAAS fellow, and these questions, I have two, very divergent, very different for Dr. Glynislow. The first one is, how are the National Academy of Sciences participants selected? And the second question is, in terms of what's predicted for national crop production, because I'm interested in both biofuel crop production as well as food crops, any predictions in the next 25 years in terms of how much land will consider the breadbasket, right? Will we maintain that breadbasket identity, I guess, based on the variations, the variability that we're expected to experience? Thank you.
I think I can answer the first question about the way that your question was specifically about the way the National Academies reviewers were selected. We have a standing committee to review the U.S. Global Change Research Program, and that committee put together a panel specifically to review the National Climate Assessment. So they used their standard procedures. We had no input in who would be on that panel. Mm-hmm. It's all their standard procedures for selecting the participants. We had a whole separate set of procedures for how we select Federal Advisory Committee members and author teams and things like that. But for the reviewers for the National Climate Assessment, it was just the National Academy's process. For the second one, for detailed projections about the breadbasket itself, I'm afraid I'd have to recommend that you take a look at the agriculture chapter. There's also some information in we have a chapter called Energy, Water, Land, or Water, Energy, Land. The name switches back and forth. But it goes into more detail on the biofuel question and the number of acres required for biofuels.
Down in front, yeah.
Hi, I'm Neil Ransom. I'm a PhD student at George Mason. My question has two parts. For Dr. Shukla, how are trends like demographic trends or urbanization incorporated into the climate models? And then also for anyone on the panel, are there any trends, human trends that will eventually address some of these issues or make climate change easier to address in the long term?
Demographic trends and that kind of information is not included in the carbon plan. The physical property of the surface up to the level that it is available is included, but it is not so fine resolution that it can actually take the difference between urbanization and no urbanization. So
the scenarios include some of that information?
no, I'm talking about the scenarios. They don't at this time. They don't. But they do take into account major changes, say, for example, in deforestation, in land. Incidentally, we are always talking about emissions of the greenhouse gases, but the total effect, 17% of that is because of deforestation. And in fact, if I remember right, Brazil's contribution to reduction in emissions is cutting less forests.
It's one of the big contributions.
There are big contributions, yeah.
That's one area where there's some ongoing research into scenarios, as well as how do we, through the U.S. Global Change Research Program, how do we represent those sort of demographic trends in future scenarios? The second part of the question, I don't have an answer for.
If you drive around Montgomery County, you'll find trees being planted all over the place. If you try to do a development out there, you have to plant trees over a huge kind of reforesting the county out there. But
Well, what kind of trends were you interested in, Neil, other than this?
Well, just if population is projected to kind of peak at some point, and that decline will eventually decrease the effort that we have to put in.
Oh, okay. IPCC studies and models don't include that. But there are several individual researchers who are actually working on this problem. In fact, there's one at University of Maryland, Eugenia Colney, by the way, the one know, who's building a model which has climate, population, and income equality. It's the 3 parameters. And she shows that if you have a society which has a huge income inequality, then the climate and population forces will bring it to a collapse within a few hundred years. So there are a lot of people who are studying that problem individually. Paul, there's in the corner, somebody is raising hand.
But in the corner back there.
I can't,
in the shadow.
Sorry about that. My name is Alejandro D. I work with the Inter-American Development Bank. And so my question is related to economics, of course. We have heard about the science and the impacts of climate change, but we haven't heard about what are the costs of climate change. And when I imagine the conversation with the finance ministers, anything that is not in dollar terms is basically something that they are not going to pay attention to. So my question is specifically with respect to the exercise for the U.S. is, have you assessed what are the costs of climate change impacts and what are the costs of doing something, adaptation, or the cost of mitigation? What are the options?
Okay, now I'm probably not very qualified to answer this question, but I have read a few reports, the old ones, for example. We all know about the Stern report that was prepared several years ago when he was a World Bank economist. And he came up with the kind of an estimation that in order to do a mitigation, it will cost about 1% of GDP now. But if we don't do anything, it will cost 10 to 20% of GDP, global GDP, which is a very large number. But then there are a lot of economists who don't agree with him because of his assumption about the discount rate. And to me, it was quite a revelation because I went to Yale University. There was a discussion following his lecture. And all these economists, all they talked about the discount rate. And I raised my hand. I said, I'm a climate scientist. We're really worried about global warming and so on. But I had no idea that the future of mankind depends on discount rate. But obviously it does, in their opinion. So maybe somebody else knows more about the US part. I know the Nordhaus, who is another economist, Ariel. He has actually written a book, just came out, is called Climate Casino. And I'm told that he has made some estimates about the kind of question you are asking, but I don't know any details.
For the national climate assessment, the economics question is something that we've identified as an area that could benefit from future research. There are actual costs for mitigation, adaptation measures, and impacts in the U.S. are not very well defined. The report includes that type of information where appropriate data and information was available. You also might be interested, the National Academies, I believe it was last week or the week before, it was in the month of December, they had a panel, a public meeting about a potential valuation project that they might be interested in. So the materials from that workshop should be available online.
Well, if there are no more questions, we've come to the end of our time. I'd like to thank our panelists for such an excellent presentations today. And thank you all. Thank you for coming. Thank you for your very insightful questions. We will be back in the university world we call next semester, which is sometime late in January before we get going again. But we're lining up a series for the spring. Be glad to see you then.